So you should have already watched the longer video explaining solubility curves. He really does an excellent job explaining what they mean and how to read them. But there was one part that he left out that I do want to talk about, and so I've made this second video. So this is the handout that you're going to be working on, and this is the graph that you're going to be looking at. If you look on the back side of the page, there are these 4 questions in a table. And I'm going to go through how to answer these questions because they're a little bit different. The first thing that you'll notice is that it says a solution contains 70 grams of sodium nitrate in 30 degrees Celsius in 100 milliliters of water. So the interesting thing about water is that its density is 1 gram per milliliter. So 100 milliliters is 100 grams. And 100 milliliters here would also be 100 grams. And so if you look at this graph, all of these are in 100 grams. So that makes this really easy. You're just essentially reading the graph. But when you get to the third one here, it says it's in 200 milliliters of water, which is 200 grams. Well, we don't have a separate graph for 200 grams. We only have our one for 100 grams, but we can use ratios in comparison to figure out what this is. So it says a solution that contains 40 grams of potassium chlorate at 50 degrees Celsius in 200 grams of water. So we're going to make that a ratio. 40 grams in 200 grams of water. And then we're going to go look at our graph, which is actually in 100 grams of water. So the temperature here is 50. And if we look at this ratio here, we can solve for what that top number should be. So you can cross multiply like you were taught in math, but I like just doing the comparison here. So 200, half of that is 100. So 40 is the top, so half of that would have to be 20. So when we're looking at our graph, we're really going to be looking at 20 grams, not 40 grams, because 40 grams is in 200 grams of water, but 20 grams would be in 100 grams of water. So we're going to go look at our graph for 20 grams of potassium chlorate at 50 degrees Celsius. So 50 degrees Celsius is here, and 20 grams is here. So we're going to draw a line connecting those. I made my ink pink so we could see it. And sure enough, that sits right on the potassium chlorate line. So that means that this solution is saturated. Remember, any point on that curve is a saturated solution. This last one says there's a solution containing 35 grams of Ki at 0 degrees Celsius in 50 milliliters of water. And again, that 50 milliliters is really 50 grams of water. So we're going to make our ratio again. This is 35 grams in 50 grams of water. We want to know what it would be on our graph, and our graph has 100 grams of water. So again, this 50 has been doubled to make 100. So if we double the top, that number would be 70 grams of Ki. So we're going to go look at our graph again at 0 degrees Celsius and 70 grams. So 0 degrees Celsius is here, and 70 grams is up here. Really don't have to make much of a mark there because it's right on the origin. And Ki is way up here. So our mark, 70 grams, is below the curve, the line for Ki. So that means it's going to be an unsaturated solution. You kind of have to write it here in the middle to fit it in. So it's unsaturated. The second part of the question then says, if it's unsaturated, how much more solute can dissolve in the solution? So our mark here is for 70, and we could go all the way up to 130. That means we could add an additional 60 grams. And again, that's a little bit trickier, but I wouldn't worry too much about it. Please email me with questions.